our next talk, like coming from the Apache Pinot community. I've met Corinne and Rong in another open source conference, and I learned a lot about their work with Apache Pinot and StarTree. So I'm very glad I can bring their work here to our Alluxio audience today. So we move on to the last talk of the day with Corinne Wallach and Rong from StarTree. Unfortunately, Corinne, due to her schedule conflict, she couldn't be here today. So we just have Rong here to join us. He can handle the show on his own, I'm sure. So Rong will go over the real-time analytics going beyond stream processing with Apache Pinot. I've met with both of them at a conference and I did learn. So I'm very glad I can bring both of them here. So even though Corinne could not be here today, I'll still give a brief introduction in case you guys want to say hi to her. She was the one who also introduced me to Rong, our speaker today. She is a head of development community at StarTree, and then she was doing broadcasting before in the background in major entertainment, and somehow stumbled upon the tech industry. And Rong, our presenter today, is a software engineer at StarTree. He is also a committer for Apache Flink and Apache Pinot project. Prior to StarTree, Rong has also worked as a software engineer at Facebook, Uber, and LinkedIn, and practiced as a barista, bartender, and guitarist for 10 years. I yet to need to see how awesome your other skills are. So I always had a very pleasant conversation with Rong. He is a very strong engineer as far as we know. We've seen a lot of his contributions even back then. So without further ado, we move on to the last talk. Let's hear from Rong for the very last talk of the day, real-time analytics going beyond stream processing with Apache Pinot. Go ahead, take it away.
Hi, thanks for the warm introduction, Jasmine. So let me try to share my screen. Actually didn't do this previously, just want to make sure. Can everybody see my screen by any chance?
Yep, we're good. Awesome,
great. Yep, so since Karim is not here, I'm just going to be presenting by myself. So I'm going to do this a little bit less formal. So if there's any questions, feel free to interrupt me. But I'm just going to go over some of the high levels regarding how our views from the Apache Pinot communities on going beyond stream processing into user-facing real-time analytics. So here is kind of like a summary once we actually get into 2022 and see from a lot of our customers, of our users, of the Pinot communities, they seems to start evolving the real-time analytics into kind of like a real different domains that we never seen before. Some of the examples that we've seen a lot, for example, dashboarding, BI tools. These are the things that a lot of our users, engineers, they are all familiar with. Like you play around with dashboards, you maybe slice and dice, drag and drop, etc., etc. These are the use cases that we've seen a lot, but we are actually seeing more and more for our end users directly using these rather than going through their engineers or their scientists. Not to mention machine learning, I think like previous presenters already talked about this, is we are actually seeing more and more machine learning systems directly tapping into real-time analytic databases, trying to pull data out, train their models, or even actually trying to incrementally improve their models, and then doing the inference at the same time. But all in all, the most important thing that we want to talk about here is we're not actually just presenting the data to the users. We are actually trying to present an actionable items or actionable insights, not just for presenting the rows and columns for the sake of it, but also actually telling the users, like from the machine learning perspective, this is the things that you're actually supposed to do. And from the data analytics perspective, these are the things that you actually action item you can take. So this is one really good example is using LinkedIn's Who View My Page or Who View Your Profiles, or another one of the examples is the talent insights, where a lot of the recruiters actually uses these tools to track their performance, what they can do better, what are the employments that gets more engagements, more convergence rates, etc., etc. So these are all actual numbers that is actionable, not just a whole bunch of dashboards that end users requires more further processing in order to understand or process the data. Another example is the Uber Eats restaurant dashboard. Right? So the restaurant dashboard was actually presented to the restaurant owners to tell them exactly what happened in the last couple of weeks, couple of months, etc., etc. Why are the orders missed? And the reasons why the order was missing is because the drivers too long, it was because the preparation time is too long, etc., etc. And it also tells you what are the inaccurate orders, which one of those are actually because of like customizations, or some of them is actually just purely because of human errors. So all of these things are actually driven us going beyond kind of like a business insight, business analytics, going into an actual tapping into the end user world. So our customer was actually using these type of systems to power their direct business. So the reason why we're actually trying to do that is because users and customers are actually the closest to their business monetization. These insights directly translate into monetization gains for their businesses. So in the technological perspective, here are some of the insights that we can summarize. So we are translating from internal facing analytics for like internal data scientists, data engineering teams to directly facing the user. Users are actually ingesting or processing much more semi-structured data, right? Because for the end users, asking them to sanitize the data in the beginning is just not that feasible for them to be onboarded or to get going. A lot of the queries are requiring strong data accurate consistency, so we no longer can just provide it like P95. This is actually what you're supposed to look at. Now, these insights needs to be exact and needs to be consistent, needs to be strong consistency with the data. Previously, we are only looking at slicing, dicing queries like time series analysis, dashboard powering. Now we are actually seeing more and more of our users directly power full SQL semantics, including joins, window aggregations, especially complex event analysis. And we are actually seeing some of our biggest clusters going into the petabyte world, like extremely large data sets that we've never seen before. So to summarize is basically we are looking at better ingestions, better query, and better scalability. So now why Apache Pinot is the one of the the biggest competitors in this domain. And I think we're just going into the technological details regarding what are the Pinot's differentiators. So a lot of these systems use a column store. This is actually like a no-brainer. But Pinot's data segments are actually truncated into smaller like atomic sizes. But we are actually allowing our users to customize their own indexings and metadata depending on the use cases. So on a higher level, all of these segments are pushed on the servers. Servers are actually being coordinated and co-located using the Helix controllers. So basically they manage which segments going into where, how they're being replicated, etc., etc. And finally, we have the broker, which is basically the compute nodes that actually dispatches, optimize the queries, and then send the data out to the servers and getting the results back. So here are several of the like the most important differentiators that Pinot has, especially the optimized index algorithms. So as I mentioned before, a lot of these segments consist of like inverted index, range index, or even like kind of like StarTree index, which is basically a pre-aggregated index that instead of asking our users to run a query to aggregate a sum, a count, a mean, or max on the fly, these numbers are automatically being available without actually the users knowing behind the scene. So to summarize some of the indexings we supported, including the traditional range sorted or inverted index, we also support the semi-structured indexing mechanisms like JSON, text. This is basically making our users' life much easier because they don't have to actually sanitize the data before. We also support geo indexes, which are contributed by the Uber's engineering team. Regarding that, we also have a lot of aggregation optimizations, including hyperlog data sketchers. On top of that, StarTree index is going beyond both the worlds, right? So you can actually slice and dice no matter how you want your dimension cube to look like in order to directly read out the aggregation results instead of actually have to compute them. Another thing that I just mentioned is the semi-structured data supports, right? So previously, people just want to, previously OLAP system just want the users to process the data. Now with the JSONs and this is not working. Yeah, with the JSON text and geo indexes, users no longer have to do this. Here is our way of looking at the strong data consistencies. So in terms of real-time data ingestions, we are seeing a lot of duplicates, inserts, and insert updates and deletes. So basically, we want to make sure that the latest view of the data set is actually accurate. So how do we do this? We're actually doing kind of like an observed data ingestions. So for example, if you have some type of like primary keys that basically keys your data in the real-time streams, we're actually maintaining a mutable and immutable primary index to a segment/row mapping, so that whenever you wanted to query the latest status, like, hey, what is my latest value with this specific primary key, you can always directly look this up in the indexing mechanism. On the other side is, if you wanted to, for example, like this primary key is kind of like a session ID, you want to know all of the values through the processing within the sections in the past, say 5 to 10 minutes, you can actually do that, because all of these numbers are not actually replacing the values on the segments. They're actually appending to it, but adding a key index updaters behind the scene for fast lookup. One more thing we wanted to share is how we handle the full SQL semantics requirements on it. We are actually switching from a single scatter modes. For example, the broker actually deal with a lot of the final combined aggregations and then serve the results to the user. We are actually trying to insert dynamically number of intermediate compute stage, so that we can process much more complex SQL semantics like joins, aggregates, and match recognize, etc. Another thing that we just rolled out this year is a compute and storage decoupling. So actually, you can imagine, right? A lot of the times the compute and storage are co-located together. This causes a lot of cloud resource waste, because you are not actually utilizing most of the compute. You're actually using the local storage to store the data. Now, what we actually cleverly implemented this is, once we get into the terabyte world, we're actually moving some of the coded segments from the local storage to the cloud storage, so that you don't have to pay the cost for local storage correlated with the compute node that you're actually not using those compute resources. This way, we are actually going to scale much better in terms of the cost to serve a specific segment. The reason why this actually works is because of the nature of real-time analytics queries. So the more closer the latency to the current, the more likely that segment is going to be queried out. So we smartly swap these segments to and from a server, so that they can actually keep the most used segments locally and keep the least or cold segments on the cloud storage. But yeah, as you can see, the cost to serve in this specific setup is extremely low. So to summary, the takeaway is real-time analytics has been involved a lot of the direct user-facing actionable applications to power, and Apache Pinot is our solution for this. Specifically, we have excellent query performance. We handle real-time data mutation really well using Observe. We ingest data from all sorts of data sources. We also support semi-structured data. At the same time, we actually have a hybrid architecture for cost efficiency to run in a large-scale cluster. Basically, with the indexing support, the ingestion support, and Observe support, almost all of our platforms are actually built to tailor to all kinds of use cases. I think that's all I have in terms of my slides. Any questions?
You flew through those slides.
Yeah, I mean,
yeah.
Some of the previous slides were actually supposed to be covered by Karim, so I just hope that doesn't actually cost too much.
Not a problem. Definitely a very hardcore engineering style. So, well, I do have more questions. So, does it make sense to use Apache Pinot alongside with any other analytical compute engines? So, if so, if you're what kind of pipeline would make sense?
Yeah, that is a good question. So in the very beginning, Pinot was actually designed to directly powering dashboards. So some of the systems that it actually works pretty well with is, for example, Apache Superset. you can actually tap this into a Pinot as kind of like a data sources. It supports JDBC connections, etc., etc. But Pinot is not a system designed specifically for long-running queries, right? So if your query actually takes, for example, 1 minute, 5 minutes to finish, it first of all will hog up a lot of resources on Apache Pinot. So your Pinot cluster will be solely serving that query. So for these type of workloads, we're actually suggesting our users to tap it into a connector with Presto or Trino, or some of these like pipelines that says scheduling type of query engine, so that they can actually run them really fast. We also have a lot of optimizations to connect with, for example, Presto and Trino, because in a lot of the time, what you actually want is to make the heavy compute happening on the intermediate compute stage. But at the same time, what you actually want is to ship as little data as possible from the Pinot engines all the way to your intermediate compute engine. That way, we do a lot of optimizers, planner optimizations, predicate pushdowns, etc., just to make sure that whatever that we can do on the Pinot side in a sub-second latency, we should do it there. For the rest of the heavy things, we ship that into another system still. Does that make sense?
Yep. Cool. Thank you. We do have a question from on Zoom, so I'll do that first. Robert asked, does Pinot change the story around needing to pre-compute aggregates? Example, count distinct before import. Oh, I see.
I think I was actually rushing the slides a little bit fast, but let me actually just
let's go back to it.
So one of the things that I didn't actually mention previously is that all of these indexing mechanisms, they are supposed to be dynamic, right? So we don't generate the data, or we don't generate the index alongside when a segment is generated. What we actually do is we generate the index on the fly when the segment was actually loaded from the cold store to the host store, to the server. So indexes are generated on the fly. The reason why that is because, for example, we have a much more efficient range index algorithm, like it's actually being contributed around 3-4 months ago by another company. So what we actually wanted to do is your segments should not need to be changed for these index algorithms to benefit for your queue. Now, for all of these pre-aggregations or pre-computes, these are actually configured in the StarTree index. So StarTree index are basically a future optimizations on top of the aggregation. So if one of the examples I can see here is you have, for example, 2 layers of dimensions that you wanted to slice and dice, country and browser. What it actually do is for each one of the aggregation you want to do, like count distinct, etc., etc., the StarTree index will be generated on the fly when the segment is being loaded. For example, the root will be all of your distinct counts. And then the first layer on the left will be all of the distinct counts grouped by US, when the US, grouped by country when the country is actually US. Now, all of these numbers are actually computed when the segment is loaded. We don't actually compute any of these StarTree indexes. So that way, if, for example, our customers say, later on, I forgot to add one index, I want to add one more on the slice and dice columns or dimensions, or I want to add another, for example, sum or even covariance pop or something like that, kind of like a really complex aggregation algorithms, they can actually do that. So to summarize is index are customizable, and it can be hot swapped out, in and out, depending on the use cases, in order for us to support more complex and more user-facing analytics.
Cool. We do have a couple more minutes. Do you mind talking about some of the, possible future work and future roadmap for Pinot?
Oh, yes. Yeah. So one of these slides were actually talking about future optimizations. For example, in here, we have JSON and text index. We also have Lucene integrations that is going to be further optimized probably in a quarter or within the year. We also have another V2 of the Azure data ingestions algorithms that we are actually planning to support going into the future. So to some of the prior knowledges is segments in Pinots are not mutable. So once the segment is generated, you can't actually go in and change the segment. one of the reasons why we don't generate the index along with the segments. But in order for us to support a more efficient scheme, what we actually want to do is we want to make the segments buildable. So that was actually a big effort for us to go through. Another one is the full SQL semantics. We are actually in beta phase for the intermediate result computational stage, which is our V2 query engine. This engine right now actually supports up to probably 3 to 4 layers of computational intermediate stages. We are actually trying to come up with a much more complex compute stages so that we can support a more complex query, so that you don't have to shift a lot of the workloads that you're actually doing right now from Pinot to Breast. Yeah, that's probably what I have in mind in the upcoming half a year to a year.
Okay, cool. Robert did have another question from Zoom. What's the estimated release date of multi-stage query execution and joins?
Oh, actually, you can run it right now. For multi-stage query execution engines, other than performance implications, you can run as complex of a join you can want. You can join like 3, 4 tables, 5 tables, 6 tables together, as long as your joining results are like small enough for the entire engine to be run in subsequently, because we basically kill the queries once it is going beyond, say, like 2 or 3 seconds, because a lot of the times when you're actually running these heavy queries, you're helping out the resources for the entire cluster, which means that your other queries are not getting enough resources to run, and they will be slower. So as for safety concerns, we're actually trying to limit the amount of time you can actually run these type of execution. But at the same time, you can definitely run any types of joins, goodbyes, semi-joins, over aggregate, etc., but as complex as you want.
Cool, awesome. I think we don't have any more questions coming from Zoom. I'm good. Thank you, Rong, very much. We're pretty much on time.
Yeah. I always like to see that we are actually a little bit.
Yeah. You are flying through the slides, but it's fine. We'll share that. So in case people do want to go back to the slides, we always have that available on our website. And you can always find Rong, either on our Slack or on the Pinot Slack. I'm sure you're on it. So maybe I'll post that if you would like to, and any links on our Slack channel as well. And so people can find you if they need to, look for you. All right. Thank you, Rong, for sharing.